Welcome to Feature Fridays. My name is Guy Bartram, and today I'm joined by Romain. Romain, you want to just introduce yourself?
Hi, my name is Romain Decker, and I'm a staff technical product manager in the VCPP program, covering everything networking for cloud providers.
Thanks, Romain. And as usual, everything networking, you're the expert in that area. And today we're going to talk about NSX-T and VCD 10.3 and the new capability with vApps. Romain, just want to kind of rewind a little bit. 10.2. What was available there, and what's different in 10.3, and why is this like a super important update?
Yeah, sure. Without going too far in the history of VCD, we started to support NSX-T in multiple steps. So in the 9.x versions, we supported to consume objects created in NSX-T and consuming those in VCD to connect VMs and so on. And then we started to support also T0 gateway. And then in the 10.2 versions, we added distributed firewall supports, data center groups, VRF gateway supports, and the NSX advanced load balancer for the load balancing as a service, and so on. In 10.2.2, which was the May or the April release this year, we supported directly connected or VDC networks for NSX-T VDCs. And now, so 10 days ago, was it July 15th or 16th? We had our GA of VCD 10.3. So it was a major release. So I won't go through all the features here, but the main features are the vApp edge services for NSX-T VDCs, virtual data centers, and also dynamic groups for distributed firewalls based either on OS names or on tags. Also a lot of small UI changes so that it's less confusing from a provider point of view. And what else? Yeah, a lot of enhancements also in terms of rearranging external networks and T0 gateways. Now you can have NSX-T segments as external networks and so on. But the vApp service, vApp edge service, was a long-awaited feature, which is now here in the product and that you can consume today.
Yeah, I mean that's it in a nutshell. We've all been waiting for vApp and vApp services. So from a vApp perspective, obviously it's the grouping, if you like, of the entire environment running an application or whatever you want to group. The edge part provides you the network services, right? So the DHCP, the firewall, the NATs, the routing, and there's different types of vApp edges, right? There's vApps. There's a rooted vApp, which is able to communicate with the VDC. There's an isolated vApp, which is isolated from the VDC, and a direct. What's the direct vApp? Do you know what that network type is about?
I'm not sure about the naming here. I never heard about the direct vApp. Okay. So in VCD, so you have the three layers of networking. So you have the provider networking, which is the external networks, which provides connectivity to the outside world. Then you have the org VDC networking. So those are the networks that you define at the org VDC level or in a data center groups. So gathering together multiple org VDCs. And so those can be with NSX-T, routed, isolated, direct, and imported. So four different types. And then you have that specificity of really of VCD with that vApp construct where you can have either connect the VMs directly to an org VDC networks, no matter its type. So it can be direct, it can be routed, and so on. And that may be the direct vApp that you mentioned. So you connect directly the VMs from the vApps to the org VDC networks. But the specificity of VCD is to have another layer of networking, which is the vApp networking, where you can have routed or isolated vApp networks. And
Right.
before 10.3, we were able to create isolated vApp networks, which was basically an NSX-T segment. And now with 10.3, we also added the routed vApp networks and the support of DHCP for isolated vApp networks.
Awesome. So we're pretty much, when it comes to vApps, at parity where we used to be with NSX-V, and NSX-T is now providing all those services. Okay. Should we dive into a bit of a detail then of what the vApp construct looks like?
Yeah, sure. Let me just share a couple of slides before switching to the demo. So basically, the vApp edge service now in NSX-T is based on a standalone tier 1. And that's not like an official name. I'm just using that as an adjective. It's just because the tier 1 is standalone. It's not connected to a layer of T0 gateway.
Yeah.
So if you're familiar with NSX-T, you have that concept of dual layer of routing. So the T0 or VRF gateway, and then the tier 1 gateway. And that's like very common, and that's the model that is used by 99.99% of our customers. And to cope with that vApp edge service use case, what we did is that we instantiate a new tier 1 gateway, and we use the service interface to connect to an ORVDC networks. That ORVDC networks needs to be an overlay network. Yeah. And the service interface, if you may have heard this also as a CSP, which I don't remember, the centralized service port.
Yeah.
It was named CSP before, and it changed in NSX-T 2.5 or 3.0, if I remember correctly. Now it's a service interface. It's basically an interface going from the SR component of the tier 1 gateway, so running on the edge node, and connecting to that ORVDC network. And using that, we have those tier 1 gateway that will act as a vApp edge service, as a vApp edge. And they can provide the same capabilities as in NSX-V, so firewall, NAT, static routing to up or to down, and DHCP. And DHCP just for the isolated type.
So really the service interface here is the capability that is allowing us then to use a T1 as a vApp edge in a nutshell. Yeah. Okay.
Yeah. Otherwise, we wouldn't have like a connectivity. So otherwise, the vApp edge would just be sitting there, not connected to anything.
Okay.
So the service interface is what connects. So if I use the last pointer, the service interface is what connects the vApp edge, so the tier 1, to a routed or an isolated or an imported network.
The ORG-VDC network, essentially.
Yes.
Yeah. Yeah. Okay. And what's the no fenced vApps? What is a fenced vApp?
To be 100% honest, I don't remember the details. That was a very specific niche use case that was for NSX-V and the vApp edge. And it was to close, if I remember correctly, really to enforce some closing around the vApp in terms of networking, but I don't remember the specificity.
Okay. And edge cluster must be configured on VDC?
Yes. So the way we are doing that, so those tier 1, because we use the service interface port, the service interface, as it's running on the SR component, it's running on the NSX-T edge node. So how do we know which edge node we have to use to instantiate this service interface? Well, before being able to consume tier 1 gateways as the vApp edge, you have to basically go in the ORVDC and define the edge cluster, so the NSX-T edge cluster to use for those SR components. By default, it's empty. If you don't do it, you won't have the tab to connect the tier 1 gateway to the org VDC networks. So it's represented here. So you have a edge cluster section at the org VDC level. It's empty by default. So you are free to pick either the edge cluster of your external networks, of your existing NSX-T edge gateways, a specific one if you want for scale reasons. And then you will have a new connection tab at the vApp network level.
Is there any, that you know of, any limit today in number of service interfaces you can have associated on a T1?
A number of service interface associated to a T1. There are, I don't remember the number. It's high enough, but what's more relevant is the number of maximum of T1 or standalone T1, because a specific T1, so that vApp edge A, vApp A edge, the green one, will only be connected to one org VDC network, so it will only have one service interface. But the total number of service interfaces in NSX-T is important, but it's a few thousands if I remember correctly.
Okay, so that's fine. All right, that's good. Just good to know. Okay, that's that's pretty comprehensive. So for rooted vApps, you basically have the whole portfolio available
Yes.
in terms of T1 functionality, firewall, NAT, DHCP, static, and then for isolated, it's just DHCP. That makes sense. Okay.
And the engineering team has made a huge effort to maintain the API and the UI between NSX-V and NSX-T, so people won't be confused by different terms or different screens that may appear. It's exactly the same. What else can I say? Yeah, it can only be connected to an overlay or VDC network. So when you connect that vApp edge to an org VDC network, you cannot use a VLAN NSX-T segment, and you cannot use a directly connected org VDC networks. It's for internal technical reasons, basically the fact that we cannot really go at scale with VLAN-based service interfaces. We can only do that for overlay-based one.
Yeah. The whole reason why you want to move to overlay in any case. Okay, that's great. So should we have a little dig around in the UIs that you have?
Yeah, sure.
Okay.
So that's my lab environment that I just upgraded to the GA version of 10.3 before I was running the internal build version. So I have two org VDCs in my alpha org. And in terms of application, I will just show you the finance app. I already configured the vApp edge, but we will do it for the compliance app. So for the moment, I only have one network. So it's only one org VDC networks. So I know that because I created it, but also with the little icon, the vApp network is different. So if I create a new vApp network, I can define a name. So for example, vApp network 01, and then the CIDR. I usually use the CIDR in the name. It's easier to remember.
Okay.
After all, I just want to define the gateway CIDR .1/24, and then you can create a DNS and guest VLAN, static IP pool, and so on. So I'll just do 11 to 29, for example. So it's creating my vApp network, but it's isolated because it's not
no connection. Yeah.
Yes. So if I check that now in NSX-T, if I check my vApp, it should be at the bottom. Yes, here. It's isolated. And if I select, I don't have anything really fancy. I don't have the services, firewall, NAT, and so on. In here, what I mentioned, if you don't have the edge cluster defined at the org VDC level, what's missing? You have a tab that is missing next to general, which is connection. So basically, you tell the VCD to which org VDC networks this vApp network should be connected to. And when you do that, the standalone tier 1 is instantiated. So to do that, I'm in data center alpha VDC 2. So if I open this one in networking, at the bottom, I have edge cluster. So here I can select an edge cluster. So I will select just this one. So it takes a few seconds. It's not doing a lot in the backend. And I will just refresh my screen, and then we will be able to actually connect the vApp. So you now have a connection tab. So in the connection tab, I just select the existing org VDC network in the vApp, and I explain that I want that particular vApp network to be connected to that org VDC network using a standalone tier 1 gateway.
And that's the service interface in NSX terms, if you looked in the NSX UI.
Yes and no. So I mentioned service interface, but that's like how it's instantiated in the backend. From a consumption perspective, it's not really relevant. I would say, for the tenant to know how it's done. But yeah, you're right. The standalone tier 1 will have a regular VIF, so downlink connected to that particular segment, and no uplink because it's now connected to a T0 or to a VRF, but it will have a service interface to the org VDC network. So if I create that, you will see additional sections that appears here. So services and routing. So if I open services, I have now the services available for that particular vApp network. So I have firewall, NAT. I also have static routing, and DHCP is also available. So you can enable DHCP. And DHCP is here, even if it's an isolated network, while the other one, services and routings, are not there if it's an isolated vApp network. So now if I go back to my vApp, in terms of network diagram, we see that I have at the bottom my org VDC network, where I have one VM connected to it, and my vApp network that is connected using an edge, a standalone edge, to the org VDC network. If I create a new VM now, or I can edit the existing VM1 and connect it to the vApp network.
Got it. It's available then for you to utilize for all of your vApp workloads and directly connected workloads.
Yes.
Okay.
And in NSX-T, it looks like this. So I need to refresh. What was it? Sorry. So I have the other one that is here. It's not the same NSX-T instance. But this one for my finance vApp, we can see if we open the network diagram. So that's my edge gateway. So that at the org VDC level. And then I have an org VDC, so the 192.168.10, that's my org VDC network. And then the vApp network, which is basically connected to that particular edge gateway. So that's the vApp edge gateway. And that org VDC network, you see a little chain icon. It means that it's connected to two different gateways. So the regular org VDC edge gateway and that particular edge gateway. So if we select in the network topology, if I select the segment name, and then I select first that one.
It pays to use good naming conventions here.
Yeah. So that's the view. It's a different view. So that's the regular path. So the T0 VRF gateway. So that's my external network. Then the T1 gateway, my alpha edge one, which is basically my
VDC.
my VDC edge gateway, this one. And then I have an org VDC network, which is net 192.168.10.0. And then I have that particular finance app vApp edge that connects that org VDC to a vApp network.
Yeah, and in this case, the finance app is this is connected to the Alpha Edge 01 org VDC overlay network. It's just the NSX, the topology view is representing it as another T1.
The topology view from NSX was not meant to represent that concept, which is more a VCD concept. So we consume different components and capabilities of NSX to provide that VCD feature, the vApp edge feature for NSX-T, but the NSX-T network topology was not meant to represent that. Maybe in the future, we have to work with the NSBU for that.
Yeah.
But basically, if I finance vApp, so that's the other one. I have, for example, I have two VMs. One is connected to the org VDC network, and one is connected to the vApp network.
Excellent. Okay. Well, I mean, that's apart from getting your head around that constructs kind of positioning. This is bread and butter vApps. This is nice and simple. Looks like you say, the consistency has been maintained nicely here, which is, I think, really important for your VCD providers and tenants. And yeah, I mean that makes things a lot easier. Looking at it in the NSX-V is useful to check, but you've got to bear in mind that it's being used in a slightly different way.
Yeah, exactly.
Okay, Romain, anything else to have a look at here? I think we've pretty much covered it all.
No, really, the main consideration is to make sure to have defined an edge cluster at the org VDC level. So you go in the org VDC, in the networking section, and then you go to the bottom and you have edge cluster. It really depends. It's basically where the service interface will be used, in which edge node the service interface will be used. So plenty of choices. If you don't have crazy scale number, you can just use a single edge cluster for everything in VCD. You can separate the external T0 VRF gateway in a specific edge cluster and then have tier one. So all the tier one in another edge cluster. That's what we recommend usually, to have different scale mechanism. But yeah, that's the only main consideration. If you don't do that, you won't have the connection tab in the vApp network.
And if you move, so a great thing about vApps is obviously you can copy them, move them, do whatever you want with them, really. They're just a group. If you move them then to another VDC, would you then have to move over the service interface to a different edge cluster potentially?
Potentially, but I wouldn't do that. If you use the same edge cluster for both VDCs, it will be transparent.
Okay. All right. Yeah, I think that's good. Oh, yeah. Other thing I just wanted to ask you about is obviously for people who are looking to move to NSX-T, this is really good because this gives them a similar or the same look and feel in VCD to managing vApps as they're used to. From a migration perspective, what sort of time frame are we looking at, just off the top of your head, for a migration to migrate from a NSX-V vApp to an NSX-T vApp construct?
Hopefully soon. We were expecting to have that capability to migrate NSX-V vApp edges into NSX-T in the next version of the NSX migration tool, the 1.3, which will be released in August. Unfortunately, we have to wait for a couple of API changes in VCD so that we are sure and when we can enforce to keep the parameters and the configuration consistent from NSX-V into NSX-T. So for the moment, we could already migrate if we would like to, but you would lose specific IPs that you're consuming, and that's potentially causing issues if you're using NAT and so on. And that's and something else also, but that's basically it. We want to make sure during the migration to keep the consistency between the source and the destination. And for that, we have to wait for a couple of API changes. So we are looking hopefully to have that in Q3 or Q4.
So towards the end of calendar year 2021,
yes.
maybe. Okay, great. Well, that's going to make people very happy. Excellent. Well, listen, Romain, thank you very much. This has been really informative. I'm really pleased to see this feature come into 10.3 and NSX-T. It's going to make a big difference to our providers who've been waiting for this for quite a while, and our tenants. So thank you very much, Romain. Always a pleasure.
Sure. Thanks for having me. Bye.
Bye.